That's basically factoring. But then you have completing the square and you have quadratic formula. So it really depends how you want to do it. You can technically do all of them except completing the square. On certain ones, like for example, on number 34, you cannot do completing the square because you don't have a b value. Remember, the b value looks like this. Let me write the arrangement. I'm using x. When you organize it and you get a 0, you have to make sure that you organize it and get the 0 on the other side. The quadratic, you need the b, the coefficient, for you to complete the square, completing the square here. So that means you have to have a number in front of the x. For example, you don't have an x term in here. You see, you have an x squared term, so that's why you cannot do it here. So you can do it here if you want to. However, completing the square, I'll tell you where I think it's best. Maybe this one. You don't want to complete the square where a is greater than 1. It gets really messy really fast. So I recommend you don't do completing the square where your a. I mean, anyway, where your a is greater than 1, but you need a b to exist. You have to have a b in front of the x, obviously. Like you can't, even though you have a greater than 1 here, you don't have b at all. You cannot complete the square. How about if I pick it for you? For example, we can do complete the square here, or I don't remember. I did it complete the square inside of there's one of these here because it's factored. We did some factoring by grouping, and then it turned out a trinomial that has a being 1 in it. But you know what? We can do it differently. We can do it from doing this one. However, I realize now why I didn't do it for this one, because this one can be done much faster if you complete the square by factoring. Okay, but anyway, I'll go ahead and dictate it. I'll tell you bit by bit which one can be done or not. Let's do it from scratch. This one you should do you should do this. You should solve it this way. Add both sides by 125. I hope okay if I don't write that. I want to make it clean. Okay, you okay?
Wi-Fi went out.
I see. Hey, I don't know how much you missed. I was talking by myself, possibly. let me start. Like, I'll dictate what I'll dictate what I think you should do here. Okay, this one, 34. Let's do it. I'll tell you. I think what's best, like completing the square, where, which one, and quadratic formula. So, add both sides by 125. I hope that's okay. I'm not going to write adding both sides. Then divide both sides by 5. Then divide both sides by 5. You get 120. You get 25. 125 divided by 5 is 25. And then this part is where you want to do a square root principle or law of square root or whatever they call it. They call it differently. So this is the way you want to do it. For this one, let me double check. Dang it. I forgot. I don't know if I did this with my other student. This is actually neither of those 3. You have to do one of those. Okay. Never mind. So you could do that if you want. I don't think you teach them. And then the answer is 5 and -5, right? I don't think your teacher will be mad about it. Okay, let's do factoring here because it's still better than completing the square. Completing the square, you need a b term again. Okay, so but this one you don't have a b term in front of the x or x term. I'm sorry, x term. B in front of the x. Yeah. Okay, so factor out 5 from here. This is the better way, the best way, for sure. Divide both sides by 5, or you neglect it because you cannot set that equal to 0. So then you're left with this here. Oh, but you got to do it by factoring. Let's do it like this. Plus 5 minus 5 equal to 0. Even though you can add both sides by 25 and then square root it. But I believe you cannot do that at all. I was doing that just now. Because it says by factoring, completing the square or quadratic formula. So this is factoring. Then you set each one equal to 0. Yeah, right, yeah. Set each one equal to 0, therefore you get x equals, skip that. I think you think it'd be fine. Yeah. Yeah, there you go. Okay. And there's an or between. Now this one, you do not want to do a complete in the square here. The reason you do have a b term or the x term, number 1 in front of the b. I know it's b, I know, but you don't want to do it because of this 3. When completing the square, you don't want the coefficient a exists other than 1. Yeah, or yeah, nothing greater than 1. There's a 3. You don't want to do that because you have to factor out the or
Okay.
divide out. It's messy. So let's do it first by factoring. Let's see. Or quadratic formula. Subtract both sides by 14 to get a 0 on the other side. Like that. And then try by factoring right away. Or,
Okay.
or quadratic formula. You can do quadratic formula here. But let me double check. Yeah.
No,
Let's
I
try
don't
this
like
one.
quadratic.
Yeah, you eventually have to do it. You know that, right? You have to eventually do it because.
Yeah.
But I'll pick. I don't remember which one I did. But let's try this. By factoring. Uh, the first term you can do. You can get it by 3b and b. The last term you can do a 7 and 2. Let's say you do 7 and 2 here. The outer, it will be 6b. Inner will be 7b. If I add or subtract, I can get that. That means this combination is correct. Just pretend that you did it
Okay.
wrong. Let's pretend you did a 7 and 2 here. You know that's 21. You know that's 2. B.
That
You
was
can never,
fine.
yeah, you never get that. So that's why you want to get 2 here and 7 here. Okay, so now we know this work, but we want a positive b. Therefore, the 7 is going to be the big one, and the smaller one will be negative because this will give you negative 6b, and this will be 7b. Therefore, I can get a positive 1b. The outside, inside, outer, inner combined. Okay, and the last
Yep.
work, yeah, the last work perfectly because of the minus 14, negative 2 and 7. Okay, then you set each one equal to 0. Add both sides, I'm sorry, so subtract both sides by 7, divide both sides by 3. So it's negative 7 third. B equals negative 7 third. B
Yes.
equals 2 in this one.
Yep.
And there's an or in between. I don't think your teacher will care for that.
Okay.
But there is a problem that when you graph, you need to know the or and the and. I don't know if you remember one of those.
Oh, is
Yeah, we
that
may.
like
I can go over
where
that.
it's like
Yeah.
shaded the same area?
Yes, I can go over that. I think that's
Not
actually,
shaded.
yeah,
It's
that one
not all in
can.
the study guide, but I
Oh,
bet it might be mentioned on the test.
well, I noticed that too. Some of the problems may not be on yours, but on his. Yeah, he has one, actually three, that he had to do for the review. I did it with him, but I'll show it to you. I don't know whether you have to do it or not. Let's continue. I'm gonna go
Okay.
ahead. A four term. You wanna if every time you do a four term, you kind of like ignore the last two and factor the first two the best you can here. The common factor for the first two is x squared only. Therefore, you're left with x inside here will be x 2x plus 5. You okay with that? Yeah, factor the GCF for the first two, and now you ignore the first two and factor the last two. If that first of the last two is positive, make sure it's positive. So factor out the greatest common factor between the last two, which is 100,
100.
and then you're left with 2x and plus 5 equal to 0. Now, if you do this correctly, you remember you're gonna have to they'll match when you factor
Yep.
the factor of the first and the last will match, and then you can write it one time in the front or the back. Or this time I'll write in the front one time, and then gather the I guess the the multiplier outside one time like this. Do you remember this right here?
Yes.
Yes. You can put it in the back, the common factor equal to 0. And then solve. This one is x equals negative 5 halves. Subtract both sides by 5. Yes. This one, you'll have to do it. You, you have to do it by, we did factoring enough. So your teacher will allow you to actually do this thing here. Subtract both sides. Okay, I'll write the whole thing. Set it equal to 0. Subtract both sides by 100. You get x squared left. And then you do the square root principle, plus or minus negative 100 here. Yeah, your teacher will have to allow you to do this part right here because you did enough factoring up there. Well, the first one, we didn't do any factoring at all. That's why you have to do it like that. Okay, this one, I think you, okay. The I inside the root comes out because of the negative root. So it's I root 100, which is I 10. Do you need me to break that down? Or okay? Let me see.
I get that. Yeah.
Yeah, if you were to break it down, it would look like this. 100 here. And I think you're okay with that. Sorry, I should
Mm-hmm.
be a little faster here. And that's why the the negative, a root -1, it's I. And then the root 100 is 10. But then this is the answer. You can reorganize it like plus or minus 10I. Final answer. Oh, I'm sorry. There are three answers here. One is -5/2. You can connect them like that. Link them. Yeah. You don't have to do the arrow like that. You're good. This is a third power polynomial equation. That's why you have three answers there. Now, doesn't always work that way because of bounce. It has to do with the concept of bounce and things like that. You can get one answer for two, like exponents, second power. You'll see. I think it's one of these. I don't know. Okay, now this one maybe a good time to do a quadratic formula. You want to? Let's do that. Okay.
Yes.
So let's do that for this one. All right. This is your A, your B, and your C. Now the reason you don't want to do completing the square because of the A being 2. B is
Okay.
fine. Yeah. If you A being 2, don't complete the square. Only do it like this one has a 1 here. Yeah, if you want to complete the square, we can do it that one if you want. Okay, anyway, if you recall the formula, it's going to be negative B, which is -3, plus or minus B squared, which is 3 squared, minus 4 times A, 2, times C, 3, all over 2 times A, 2 times 2, right there. Hey, yeah, double check my math there. It looks good. So plus or minus,
Mm-hmm.
it'd be a 9 minus, what is that? 24. So it's 9 minus 24 over 4. Continue. This you're gonna get an I complex number out of this. What is that?
Okay.
15. Is that 15? -15? I think that's -15, right?
Um,
Yes, right here.
yes.
Okay, so it's -15. I'll write the whole thing here. So continue over here. Plus or minus, you can bring out the I. The root 15, you cannot simplify it because it's 3 times 5. Therefore, you're done. So this is the final answer here. Double check that, but
Okay.
I think it's all good. 2 b squared minus 4 times a times c. Yeah, it looks good. Yeah.
Okay.
Okay, that looks good. Okay, this one. We can complete the square, but it's faster if you were to factor it. What do you think?
Okay. I think factoring seems a lot easier.
Okay, yeah, because it can work. It can work immediately. If you look at the combination, it's a net -2 -2. That's why this is faster.
Okay.
But we have to complete the square eventually. Maybe we do it for 40 here. Okay, the answer for this one, it's just going to be n equals 2 because you only need to solve for one of them. So as you can see, this one is a bounce one. It touched the x-axis once, but normally you get two answers, but since this is a bounce, so you get one answer only. Like, it's like something like this. Bounce off. The answer is 1. There's only one answer at 2. Okay. This
Okay.
one, I would do
Would you do something similar to 34?
34. Yes.
Like where
Yes.
you,
Yes,
in the sense where like you
you
find
want
out, like you move, yeah,
you,
I don't know the word, but like
you
you
want to,
take x to the second and then
yes, you want to pull that
2.
out and a 2. Yeah, you have to
Yeah.
pull out the GCF. Believe it or not, you have to do for all of them if you can identify it. Like if you look at 36, you cannot pull out anything for all 4. Like the numbers are not even. There's not enough x. There's
Yeah.
no x back there. So, but you still have to look for them always. But this one is the only one so far that you can pull out the GCF. So the GCF comes out, but then the rest. Let's see what happens here. It'll be x squared plus 6x minus 40 minus 20 equals 0. Here it is. This one turns into a quadratic, a trinomial. But no matter, you still have to set each one equal to 0. Therefore, you may want to continue factoring, or you can complete the square here. This is really up to you, but I think it's messy. Maybe you want to do it like completely on its own, a trinomial on its own. Yeah, you don't want to
Yeah.
do it in there. Okay, let's continue with this one by factoring if we can. Let me
I
see. What do you think? 10 and no, not 10 and 2. Okay, we may be forced to do something else because we cannot do it like by factoring. Okay, more 5 and 4. You cannot get 6 out of it. Like outer and like when you add and subtract. I believe you have no choice other than you can do a quadratic formula again, or you could do a complete square here. What do you think?
Okay. I
So
don't
it's
know what would be easier, but
um quadratic formula would be cleaner here, but I did a completeness square here with my other student for sure. I remember this one now. It's kind of messy if you do it here, so that's why we should leave that completeness square for this one. Is that okay?
Mhm.
But here's the problem. Now I realize why I did it here. When you complete the square, you have to divide the b by 2. When you do it here, you get a fraction. You see that b is -7. You get a fraction. You cannot. You don't want to do a decimal.
Yeah.
So that means you may have to do completing the square here, or
Okay.
or 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 we pretend we didn't do this one by factoring. We complete the square here. How about that? And then we'll do a quadratic formula here. What do you think? You wanna do it that
We
way
can do no. I think we should do completing the square for 39.
for this one? Okay. Now just
Yeah.
bear through. Okay, you have to do something clean, which is gonna be a pre-calculus way. You don't want to. If you recall, if you complete the square with I think it doesn't matter with something in front or not. You have to add both sides. You remember something about that? Complete square. After you divide it by 2, you gain
Yeah.
a number square. And yeah, this one, we're not going to add both sides. You'll see what I'm about to do here. This is pre-cal. I think you might as well learn it here. Is that okay? Let's do it.
Okay.
So let me show it to you. So that means we don't need this right now. Let me back. So let's complete the square first, and then I'll bring this down later. I'll bring the 2x squared later. Okay, complete the square just for this 3. You take the 6 divided by 2 and then square it. Now we do this and we don't gain fraction inside here. That's why we can do it. So that means you get a 3 squared and you get a 9. Now if you were to do it with this by itself, like you don't have this in front, you'll be adding both sides by and all that, the 9 on both sides. You cannot do that here because of this being in front.
Okay.
So what you're going to do is like this. This is pre-cal. Here we go. You're going to add it in between the parentheses entirely, but the way you do it has to be done exactly this way. So you're going to keep these two as is. Normally you will be bringing this over on the other side already by now, but don't worry. So, okay, keep these two together. Now, this new number that you gain, this is completing the square process right here. You're going to add
Okay.
this 9 right immediately behind it and subtract it. or you can just go ahead and bring the -20 in between if you want, but I'll bring it back here. Now this is strange because you haven't seen it before. This is pre-cal. You might some teacher actually introduce this in Algebra 2 immediately so that your student don't. It's better. It's always better this way. Now you'd be wondering, why are we doing this? This is 0. This 9 is a special number. You'll see here next step. So you do this to get this special number to factor this in front, the first 3. That's why you write the plus number of this immediately right behind this here. So anyway, try to do that every single time. But here we go. Continuing on, you're gonna factor the first 3 because you can. But I'll bracket this, okay?
Okay.
You'll see why. So if you factor the first 3, it's always this number here. It will look like this. Let me write a little bit underneath here. It'll be x plus 3, x plus 3 for the first 3 here. You don't need to even write this if you don't want. It's this number always before you square it. So here it is. It'll be x plus 3 squared. Is that okay? I'm writing in a squared form, a perfect square form. Let me see. I'll be neater here.
Okay.
X plus 3 squared. So I did this.
Why is it brackets around the
You
parentheses?
don't need to, but you still have to group
Okay.
them. You don't need the bracket, but you have to group them. You can do a parenthesis if you want, but you need to group them. You need to double group them. because if you don't,
Okay.
this will be, it will be attached to this first one immediately. But yeah, just keep it there and you'll see why after we finish. You'll see why. You could use
Okay.
a big parenthesis if you want, okay? But I'll use the bracket here. In math, they separate the grouping this way so that you discern which is which. So okay, continue on. We did the first three to get this right here, okay? But the last two here in the bracket or in the parenthesis, this turned into the bracket, by the way. The front parenthesis, back parenthesis turned into brackets. Okay, if you combine the last two, it would be negative 29 equal to 0.
Okay.
Okay, continue on. This, you can set each factor equal to 0 now. So the first factor equal to 0 looks like this. So the first answer is 0. Actually, it's a double answer. It's okay, but you only write one answer. So here's the first one. Now you have to set this whole thing equal to 0. That's why we need the bracket there. See that? So we're gonna set this whole thing equal to 0. So here we go. The whole thing means that inside the bracket, it will look like this. Let me write it up a little bit. That's why you bracket them, because it's considered to be a group together. This
Okay.
whole thing, yeah. So now we can solve. Add both sides by 29, and you're left with this here. Square root both sides. I don't do that, but I think you guys do this. But when you square root both sides, you get a plus or minus on the other side, 29. And then you have x plus
Why do you
3.
put a plus or minus?
It's something that you always do. Let me show it to you. You might remember it. Watch. How do you solve this? You know the answer is to be plus or minus 5, right? See? That's why you do a plus or minus.
Yeah.
If you recall, this, you were doing this like this, but then you introduce the plus or minus somewhere, always. So this side
Okay.
is
Yeah.
up. This side you get plus or minus. That's why. So that's why you have to do it for this one also.
Okay.
I can backtrack here. You okay now? Do you see it? We have to do it that way.
Yeah.
So you add both sides by 29. You're left with this here, squared. Then you square root both sides. But when you square root the other side, you have to introduce plus or minus. So it will stay plus or minus root 29 forever, because 29 is a prime number. But this side is x plus 3 dropped. You're okay with that?
Yep.
And then continue. All you do is subtract both sides by 3 and you're done. So if you subtract both sides by 3, you can put it in the front of the plus or minus. So
Okay.
that's it. So there are
Okay.
3 answers here. Technically 4, because it's a double on this one, x squared. So that's it. You want to bubble them and then kind of connect them somehow, or you rewrite them together with a comma. But I recommend just bubble them and kind of connect them together like that. Your teacher will be okay. Like put the line connecting them. Okay, now continue on. This one, you want to factor. Yeah, if you can, let's try it. 6 and 1, easy. A minus and minus. You get a outer negative 6y, inner negative 1y, again a negative 7y. And then the last, a negative 1 times negative 6 is a positive 6, so it's done. And then each one opposite the answer. Set each one equal to 0, therefore y equals 1. Set that factor equal to 0, that's why y equals 6. It's an or in between. Okay, this one. Yeah.
Would you subtract 144
Yeah, we
over?
have
This is one
to.
I remember. Would you subtract
Yeah.
144 over and then like the
Then we factor.
I
Is
don't know
that
what the
okay?
technical term is.
Yeah, I think you
12
want to
and
do that.
negative 12.
Yes, because that's right. Because they want you to do it the factoring or whatever. Any other way won't be allowed right off the bat. Yeah, you cannot perform the adding like like the square root immediately, but you should. But some people will do it. I think your teacher will still accept it. So, but I think this is best because we follow the condition, the instruction there, and then set each one equal to 0, and you get a negative 12 here. You get a w equals positive 12 here. And that's it. Or in between. This last one. Anyway, we already did everything. Therefore, let's do it by factoring by hand because it's always fastest. See. If I do 6 and 1, it'll be 30 too far apart to get you 13. Therefore, we do a 3 and 4 or 2 and 3 or something. Wait, yeah, I mean 2 and 3. So let's do 3 here and 2 here. If you do that, you get a 15 and then a 2, you can get a 13. Yes, you can get a 13. Oops. So
Okay.
let's
And
let me see. Plus plus? No, not plus plus because we can't do that. Let me see. If I do that, I get a 15. Okay, 15. If you can see here, it will be 15, 16, 17. So let's do that. What if I switch them? 3 here and 2 here. Okay. If I do that, I get a 10. Yeah, this works. See, yeah, don't forget just because the first time it doesn't work, just switch them. The combination you can still keep. So this will give you a 10 and a 3, which will give you perfect 13. Is that okay? There you go. Equal to 0. Outer is 10C, inner is 3C plus plus, and then you get a plus 13C. Yeah. It's okay? Then set each one equal to 0. If you
that'd
do
be negative 3/5.
fifth, and
And
then
then
C
negative
equals
2.
-2. Okay, done.
Okay.
All right. All right. What else? So we're done with this page. What about up here? Is that from the same instruction? No, it's not from the
It's
same instruction.
not. I don't
Where's
think
it
that's
coming
the
from?
end order. Oh, it's leftover from the last section, but I know how to do those.
You think you're okay?
I think.
Okay. Factoring.
Yeah,
Yes, I see.
that's just factoring. Yeah.
What do you think? Let me go back to
Um.
that page here. Okay, from here, you think you're okay? Oh, here, this is what I was telling you. He had these ones here that
Oh, that. I thought you meant. So I remember I looked up how to do it this morning because I couldn't remember.
okay.
Like, so I only looked up like which one or and meant, and
Hmm.
I thought and was like where they're pointing away, and or was where they're pointing together. And
Yeah.
it took like a lot of trial and error, but I think I figured it out.
Okay, so let me summarize this quickly. When you have or, you have to keep all the answers. If it's pointing whatever direction, you keep them all, except where there's a gap. So the answer for the first one looks like this. I don't know if you got that or not. The answer for the first one, I made it clearer over here. It's everything except 4. But the and is where they intersect. When you do the and, you only keep where they intersect. The only way this works best is when you grab each one individually, each answer, and then you align them on top of each other, with the 0 being like the middle number, I guess the placeholder, and then you extract it. The answer will look like this. Oh, I don't know if you got those. If not, I can do this from scratch if you want. I have the blank
No, I
paper
think I
here.
got it. So the only question I had while doing this is that for number 2, the answer key said rather than x is greater than -5, it said x is greater than -4. I thought that was just an error, but I was confused about that because I got
It
negative
says
5
4.
too.
Let me see. I think they made a mistake. Let me look at the work here. Add both side by 7. Subtract both side by 8. Yeah, they made a mistake. There's no 4.
Okay, that's
Yeah,
what I
there's no 4
thought. I don't
coming.
know.
Yeah,
I
there's no
got
4
negative
coming
5.
out of it anywhere. There's no 4 coming out of it. Yeah, there's no 4. Yeah, it's
Okay.
-5. But I hope you have like the -5, like 5 and 2. Do you get that? You can also express the answer looking like that, or the
So
graph.
then for the systems of equations, I didn't remember if I was supposed to do anything else, but I just subtracted all of them because they're all in the right spots. Except for the middle one, I fixed it up so y was on the other side of the equal sign. But I don't know.
What do you think? If you look at number 3, send y or equal to 1 and y equal to the other, you set them equal to each other. See that? Like the 5x minus 2 equals to 4x. Then solve for the x,
Okay.
and then you can plug that x back into whichever y.
Oh, yeah.
You see that?
Okay, so I did all this wrong, but whatever.
Yeah, the subtracting, technically you can. It's called elimination, but you only want to do it where they're actually all aligned, like this number 5. If you want to do that.
Okay.
Yeah. And I did that, by the way. I did a multiplication, and then it's like subtracting, but you add, and they one of the variable went away. Wait, before
And what'd you do for 4?
I did a substitution here because I can tell it's made to be done that
Okay.
way. You plug in the whole y into the y up here. You see that?
Because I couldn't remember how to do anything else, and that kind of confused me.
It, but it's kind of messy because when you do that, you still have to deal with the fraction as is the 3/2.
Yeah.
Do you want me to do that from scratch? What do you think?
Uh,
Unless you can
I think I
see.
got it. No,
Yeah, yeah.
Yeah, I
Yeah.
remember how to do these now. It just needed a little reminder.
Okay, good. One more time. I plug in the whole
Um,
y right here into the y
okay.
in the first equation, and it looks like this right here. Ignore the bubble. That's when I said distribute. But when you distribute, the fraction went away. Then if you do the math, you get your x. I know it turned your x equal to 0. You accept that. Then you plug in the 0 wherever you want to solve for y. And the fastest one is right here, the second equation. So you plug in your answer for x being 0 into here. The only thing you got left is negative 3/2. Yeah. And I remember checking
Hmm.
this. Yeah, I think this is right. Yeah.
Um,
Okay, what else? Did you get your piecewise?
where's the
Okay.
last thing? I piecewise, I really get. I really good with piecewise. I
Okay,
can
good,
get
good, good.
them.
And the graphing, I hope you're
Um,
okay based off the graph, domain and range.
yes.
Okay,
Um,
what about over here? Oh, the absolute value.
mm,
You remember how to do that?
I where is that? What page is that? 15, 17?
Yeah, 15 to 17.
Oh. I is that so to get this from what I got, you have to like make the whole thing negative and the whole thing positive as well. And that's how you get both your solutions.
Yes, but you want to do it if and only if you have it in this form. Like, okay, for example, number 15. You only allowed to do that if you isolate the absolute value, I guess, the expression on one side only. You're only allowed to do the plus and minus if and only if you isolate. Like number 15, it's already isolated on the left side entirely. The absolute value, the whole thing. If you had something like, for example, 5 in front timing that, you cannot perform the plus and minus yet. You have to divide
Okay.
that 5 away.
So I can't do that with 16. I'd have to
Yeah, you can.
subtract the
So
7.
yes, you have to subtract. And now, after you subtract, you got the absolute value expression by itself on one side. Oh, number 16 is special. Have a look, okay? I don't know what you
Oh,
did.
really?
I don't know what
I
you
did it wrong. I did all of
yes.
these wrong, but I
So,
reviewed it otherwise.
do you want to do it from scratch? We can do it. We can do it from a blank
Oh, yes,
blank
please.
page. Okay, let's do it. Yeah, there's something special about that number 16. There's no answer. I'll explain. We can jump to that right away if you want. Let me see. Put in auto. I think it's this one. No. One second. Let me do it again. I technically can actually zoom in, right? Let me see. Oh, yeah. But still, where is it? Why is this blank? Why?
Uh,
Is this one? Let me see. No. Sorry. One second. If not, I can go off that page still. Why can't I see it? Is this one? No. This one? Yes, this is the one. Okay, good. All right. So here it is. Let's do it from scratch. Okay, this one.
okay.
Now, again, the rule goes like this. You want to isolate the absolute value, but the way they write it is like anything that it doesn't matter if it's x. It could be x plus 5x, whatever, x minus squared, even squared. equals a number. Therefore, that's the objective. Once that is actually in that order, exactly in this format, you can start writing two equations out of it. How? One is like this: x equals to a positive number of that, and then x equals a negative number out of that, and then you start solving each one individually. Is that okay? Like this.
Mm-hmm.
So this one, following that order, following that rule, you do that too. Here we go. I'll do it to one side over here and one side over here. Okay, here we go. The first one, as is. I don't have to solve it if you want. Maybe you're okay. For example, here's the first one, and here's the second one. The or technically is between, by the way, if you want to write that. Here's the other equation. Everything inside of the absolute value is as is. Now, there's another way to do it when you put a plus or minus in front of this whole thing, but that's awkward. That can also be done. It's just some textbook do show you that. But here, this is much cleaner. So this is a minus 14, and then you solve each one. Think you okay with that one?
Okay.
This one works. This one works. I hope you're okay. Yeah. So there'll be two answers.
That one?
Yes, this one is okay. You think you can do that one okay?
Mm-hmm.
Yeah, I want to get to 16.
So why doesn't 16 work?
Okay, here's why. You still do this. Yeah, you still want to isolate the absolute value expression because of that rule. So subtract both sides by 7. So, and then I'll rewrite this to make it clean. It's what you have left. So the absolute value equals to negative 5, right? Yeah. Okay, have a look. Absolute value of anything, it doesn't matter how you do it, will never get you a negative number. That's why. Think about it.
Oh.
Whatever you put in the absolute value, pretend you go ahead and try it like a Q. Whatever you think your Q is, I think you might have solved for a Q. Put it in there. Check it. You can even check the original if you want. I recommend you check it right here. You know, whatever you do, you plug in the Q, you'll never ever get a negative number out of it. For example, if I put in, I think your Q might have been a 2. If you put in a Q being 2 in there, have a look. If you think your Q is negative 2, so I'll put it in to show it to you right now. So I plug in the Q being negative 2 inside the absolute value right here, or up there if you want. It doesn't matter. I'll go back up there if you want, but I'll do it here first. See, it's not true because this here is 5. 5 is not equals to negative 5. See that?
Yep.
Okay, now I'm gonna go and plug it into the original. Let's see. Negative 2 here, okay? Original says it's plus 7. Will that give you a 2? No. Here's why. Because if I simplify this, it's a negative 5 in between the bars. It turned into a positive 5 after you evaluate the bars, right? After you deal with the bar. So here, it's never equals to 2. That's why. But it's more obvious if you actually look at the step where it's a negative number on the other side. So anytime if you ever isolate the absolute value expression and the number on the other side happens to be a negative, you stop right immediately and say no solution. Is that okay?
Okay.
Yeah. So right here, I would slash through it. You don't have to slash through it. It doesn't matter, but you have to say no solution. I would slash through it and say no solution.
Okay.
Now N. Okay, this one is fine. Divide. Here it is. You still cannot actually split into two equations because of this 8. You have to divide it away. Just that part right there. If you divide it away, then it will turn into the form that you're looking for. So it'll be 8 on this side. Then you can start that particular arrangement or whatever. You split them out into two equations. Here it is. Equals 8, and the other one is equals negative 8. And then you solve, and you accept all the answers that you've got, whether they're negative, positive, it doesn't matter. So you work your way and you get your B, 2 B's coming out of it. Whatever you get here, you get there, you accept. So I'm pretty sure I'll tell you that number 16 will be on the test. Of course, with different numbers.
I bet that.
Yeah, you're always going to get one. At least one that you'll see no solution somehow. Yeah, so look out for that. For sure. Okay, now I'm afraid that you may have something that he doesn't have. I don't know, unless you recognize every single page that I've shown you, like
I
the,
do. So far, I
that
have.
means, yeah, that means you need to,
It's just printed slightly different. Like,
I see.
it's not like in a different order, but like they cut off in different spots.
I see, I see. Okay, then what do you think about this one? Do you think you're okay with these?
I think I got the eyes. I think
Yes.
the
But
eyes
make
make
sure,
sense.
okay, quick review. Make sure you know these. You only allowed to write your
Yes,
I.
I wrote this down.
Yeah, and then I squared equals to -1. You're only allowed to write -1, not I squared. And I to the third, if you come
Yes.
across I third, that's negative I. You're allowed to, yeah, you're allowed to keep negative I. But sometimes you blend in, you might have something in front of it, a negative, and it turn into a positive, whatever. But yeah, you go from there. And then I to the fourth, if you come across I to the fourth, it's 1. You're allowed to write 1. Sometimes if you, actually more often, you get I to the 0 power, it's also 1. So that's a special case there. When you do long division for these ones here, divided by 4. If it's divisible by 4, you're always going to write I to the 0 power. Zero remainder, zero remainder. So yeah, there's more to it than that when you show the work in the beginning when you learn it for the first time. But this is the quickest way. Yeah, just write I to the denominator and evaluate based on these here. I to the denominator. After you divide it by 4, the big number, the exponent by 4.
Okay.
I hope you're okay with factoring. What about 29? Do you remember how to do 29? Because
Um.
you need to use a particular formula.
Oh, 29. Yes, I remember how to do that.
Okay,
So
so
it's like the a plus b a a squared
minus,
minus
yeah, it's opposite.
ab
Yeah, like right there.
plus b.
B squared.
Yeah,
Right?
plus b squared. Yeah.
Yes. So you need to use it, but you cannot use this directly. You have to rewrite. You have to rewrite it in the form of a to the third, b to the third. Here it is. To write it, it'll be
Okay.
two x, and then you continue with it. 2x to the third plus 1 to the third. Now you have your a and
Okay.
b. Yeah. So your a is 2x. Your a is 2x. Your b is 1. Then you can start substituting it into the formula. So the answer should look like this. 2x plus 1, 2x squared, which is a squared, it's going to be 4x squared minus 2a, I'm sorry, 2x times 1, which is 2x, and b will be 1, b squared. So this should be the answer. Oh, and then if you didn't remember, I was telling you and
Yes.
my other student, the last three can never be factored, coming from the formula of the sum and difference of cubes. The trinomial, the last one right here, will never be able to continue. You don't want to attempt to factor further because it says factor completely, right? Some of you guys may
Mm-hmm.
attempt to factor the trinomial because it looks like it's one of those problems that you do. You cannot factor. So just recall, not factorable. The last three,
Okay.
trinomial. Yeah, not factorable. So don't waste your time there. However, you can still set them equal to 0 and you get you do a quadratic formula out of it. If what I'm saying is this,
Okay.
I remember this. You guys had this one before, not on this review or anything. You had something like this. Take a look. 29. I'm modifying right now. Number 29 can be written like this, equal to 0. That means you have to set.
Yeah.
Yeah, you factor the exact same way. You do this, and you set this whole thing equal to 0. The first answer. Don't forget, I'm making this up. The first
Yeah.
answer would be x equals -1/2. But the last two, you have to do a quadratic formula. You're going to get an I out of it. You can do a quadratic formula with A, B, and C. Then you get I promise you get a negative inside the. I can't say that 100% because I think, man, I don't remember this. You either get a negative, or you don't. But the answer will not be a nice fraction, nice number. It'll be a root number. If you don't get a negative, if you don't get a negative root answer, like complex I coming out of it, you still gonna get a root number in there. Okay, I think I'm right. Yeah, it doesn't have to be an I coming out of this. You may have an answer that looks, I'm making this up. You may have an answer that looks something like this. 5 plus or minus a root of 29 over 4. I'm making this up.
Okay.
That's also possible, but you can only get this answer if you use a quadratic formula to get it. Is that okay? Yeah, so
Mm-hmm.
just in case you get this one. But you did get this one on
So,
the other test. I remember it. Yeah, or the other review at least.
so really quick, when you do get a quadratic formula, but you can't like simplify it any further, when would you end up dividing it the bottom out? And how much of it would you divide out? Like, I
Divide.
don't know what's a good example. Like, if I got
Like,
-4 plus or minus the square root of I don't know, some number divided by 2, when would I divide by 2, or would I just leave
oh,
that alone?
okay, I do know what you're saying. Okay, I get it. So have a look. I'm gonna make up the answer. Okay, pretend. Yeah, I do know what
It's
you're
just,
saying.
I don't know, just some random numbers.
Watch. I'll bet this is what you mean. Okay, pretend you got to this point here. Let's say 3, and you get a 2 right there.
Yeah,
Okay,
that's something like
okay,
that.
okay. Now, if you look at these 3 numbers, if they're all of them is divisible by a number, which is in this case is 2, all of them divided by 2,
Okay.
then you have to continue. So here, let me show it to you right now. So if you continue, there's 2 ways of doing this one. If you know that this denominator can go into both of them, you do that right away. Again, there's another way to
Okay,
do it too, but
but
for it,
do I
okay,
not divide the radical as well?
no,
Or,
yeah, I see what you're saying. Let me show you why you can't do that. If you had 2 times 5 divided by 2, if you recall, you only cancel one of them. You don't touch the 5.
yes.
If you can, if you can cancel, you cancel. But if you don't touch the 5, that means you leave the 5 as the answer. That's the same idea here. You only cancel that and you leave the root 3. See?
Okay.
You know what I mean? Like because if you continue with this step, if you show all the work, it will look like this. Here we go. Watch. You divide 2 in the first and the last, the first term and the last term. It will look like that. And this now relate to that concept. You only cross cancel the 2 and you leave the 5 as the answer. That's why you only leave you cancel here, you leave the root 3. See, you don't touch
Mm-hmm.
that root 3. You were asking me just now, can I divide into the root 3? Even if root 3 were a root 6 or something, right? Like a root 6, you cannot divide 6 by 2 in the root. You can't do that either. Yeah, you're only allowed to pick one in front, like whatever one of them.
Okay.
Wait. Pretend if this is where just what you have left, you still cannot do anything with it. You have to leave the answer like
So that's
exactly
just the
this. Yeah,
solution?
yep, that's the solution or part of the
Okay.
solution. Something in front or whatever, plus or minus.
Yeah,
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 so you
yeah.
can't do it. Yeah, yeah, you cannot. They're not like terms because 2 is not inside the
Okay.
root. Yeah. Okay. Anyway, the final answer will be this for this one that I made up. Okay, this is an example. It'll be a minus 2 plus or minus root 3, like that.
Okay. Because I
Now,
always thought you just, if it was divisible, you had to divide everything.
yes,
Everything.
and here, what if it's not? Here's another made up one. Okay, if you get a
Okay.
negative 3 plus or minus, let's just say just a root even 2
Yeah.
over 5, you have to stop here. You see
Okay.
why? Like x equals.
Because nothing can
Yes,
divide with each other.
yes. Now, but let me make it more challenging here. Let's just say this is more advanced, but it still can be this can happen as an answer. Let's say you do your math in quadratic form, you can still get this. Watch. Let's say root 2, and you get a let's say you get a 12. No kidding. Let's just say that's the case. Watch. This is simplifiable. But the way you want to do it is like this. Since 3, 6, and 12 can be divided by 3, you want to literally do that. You mentally can say something, don't forget, this is x. You can say something like, hey, 3 can go into negative 3 one time, or negative 1 time, plus or minus. 3 can go into 6 2
Okay.
times, keep the root 2. 3 can go into 12 4 times. So here's your final answer. You still keep the root 2 in,
Okay. Yeah, yeah, yeah. Okay,
like
okay,
that.
okay.
Yeah, this
So in
can be
that
split.
case, also, if like that 2 was instead of 6, you wouldn't divide out, like, if you wait, go back up. If that 2 was like a 6 or something, you still had to divide out the 3, would you still leave it as a 6 in the radical?
You mean like in here, like a 6, like this?
Yes. Yeah,
Yeah,
like
you
do
still leave
something
it.
like
Yeah, you still leave
okay.
the root 6 as is. Yep.
Okay.
Yeah, for sure. Yeah.
I don't know what else. I think I'm pretty set on a lot of things. I'm
I'm
trying
sure
to
there's
think.
something. I'm sure there's something because I have a
I'm
feeling
sure.
that some of them are tricky to, like you were thinking which way you're supposed to do. So, I think there's something that, but of course I don't know exactly. But are you sure with your substitute a system of equation? Let me look at it again. You're okay with that now? System of equation?
Yes.
I hope okay.
Um, can we go over, I don't know if we have time, but can we go over graphing cubic functions?
Yes, yes,
I'm
yes.
always really confused with just that one specifically.
And don't forget, you also have these things that you have to,
Yeah.
yeah, fill up. Oh, what about these here?
Cubic
Did
functions.
we, okay, you think you're okay
I
with
think
these?
those make sense. Yeah.
Okay, okay. Absolute value, graphing? We didn't do those.
Absolute makes a lot of sense. Yeah.
Okay, where's
Makes
the
sense.
cubic function? Is this the one? And that's a repeated one, by the
Wait,
way.
did I not
Maybe here?
send it?
One of these here?
No.
Okay, let me look at the,
Well, we could still go over writing the equation for the cubic functions. Anything that has to do with them is pretty confusing for me. Like, wait, go back to that like lower middle-ish one with all the graphs. 79 with like that cubic function. That still
okay,
like confuses
okay,
me.
okay. Write an equation for this one. Okay. Now, this one, easy. Let me show it to you why. This is easy. There's a box method here that you can apply immediately, which I believe you're already kind of like using it. Okay, watch. The parent function looks like this. You have to know this one really well. So this is y equals x to the third. And guess what? The one you don't see in the front, like there's a one there, like anything in the front is
Mhm.
there's always a one. So since there's a one in front of it, that there's a box of one right here also. It cuts through the corner. Okay, by the way, it cuts through the corner, go through the origin, and cuts through the corner. Now, the
Okay.
origin can be HK. This origin is 0, 0 right now, but it'll be HK when it's moved. So this is 0, comma 0, which is H, comma K. You might be okay with that. Now, let me show
Mhm.
you. If this, I'm making this up one more time, then we'll go to the graph right away, and then it'll make sense. What if you were to graph this one? 2 to the third power, right? I'm not shifting it anywhere, so it's fine. I'm not shifting it, but just for the sake of doing the box thing. So you'll be doing box 1, 2, 1, 2 this way. You don't do it over here again. Okay, you don't overlap. You only do the overlapping for the 1 over x the rational function. You only do that overlapping box if it were
Okay.
this thing.
Okay.
Yeah, with the 2 here, you have a 2, then you overlap it. You do like this. Is that
Okay.
okay? But this is not the same anymore. Yeah, so it's not that. So okay, back to the third power. You will stack this way up too, and stack like with respect to the origin the other way. So and then you connect them through the box, through the core of the box like that. See that? It will look. It will
Yes.
still look like this shape, but don't forget we didn't do the negative. This is a positive, like a positive, a positive two, positive one, positive two. But we'll do a negative in a second here. So you think you're okay? I'll even exaggerate further. If this were 4, I'm exaggerating. If this 2 were 4, and then we'll stop here. Then we'll do this one here. If this were 4, it will look like this. You stack 4 boxes. 1,
Okay.
2, 3, 4. Square boxes. 2, 3, 4. But then when you graph it, it will go through the HK, but you cut through the corner at 4 there, and corner here at 4 there, and the corner of the box, the very last box, I guess. It will stretch out pretty narrow. It will look very narrow, at least with respect to
Okay.
the axis, the y-axis. Okay, now let's do this one with the HK. Well, actually, I'll leave it like that. So this one, the HK, you have to identify that first. So the HK looks like this. It's it's A well, the a is really the coefficient with relating to the box. I'll go back to the a in a second. But the hk, let me write the whole hk form. It looks like this. I think you might recall. Oh, the h, not k there. Oops, it's a minus there. Oops, careful. It's the h, opposite there to the third power. The same out here, k. So this is the hk form of a third power. It could be for quadratic too. This is for the third power one. For a quadratic, it'll
Okay.
still be a minus there. It'll still be a square here. It'll be a square there. But this one
Oh.
is a cube.
Okay.
Okay, so to do the graph of 79, look for the HK. Locate the HK. I think you're okay this being the HK, like, right there.
Yes.
So the HK, what is that? 2, 3, 4, 5,
Um.
6, 6 comma negative 1. All right, 6 comma negative 1.
Yes.
Yes. So here we go. We'll write it. I'll leave the A blank for now. So it's 6. You put 6 in as is, and I'll explain that. And the k in as is also. Let me see. The k is negative 1. So it's a plus negative 1. I'll do a minus 1. I think you're okay with that. Now, is it plus or minus 6? Well, if you were to actually find the hk without looking at the graph, you remember you're supposed to actually write the opposite here every single time, opposite. So
Oh.
the hk is going to be 6 comma negative 1. That's why this is true. That's why you always do an opposite, like a minus 6. So this is one of the confusing part. I hope
Okay.
you okay with that. So what that means is that anytime you write the hk form, make sure the minus is right immediately next to the x, no matter what. And then when you
Okay.
locate the graph, you just put in exact value of that. If it were over here, let's just say like negative 5, then you put a minus negative 5 in there, it become a plus 5, the third power. You know what I mean? Like,
Mm-hmm.
yeah, you're doing a minus negative 5 like this, to the third power minus 1. I'm making this up. Then it become a plus 5. So I hope you're going to be okay with that. Okay, now, so far, we've got this. The HK. Now you have to find the A. Guess what? The A that I've been showing you is the best way. It's what a lot of college professor would rather have you do instead of actually doing the table transformation. You waste your time. That's like you already waste a lot of time. You look carefully at it. Could you tell? It's two boxes. They gave you those coordinates. Look at it. See the thing that I was
Oh.
showing you, like this thing. Yeah. If
Yeah.
it if it were 4, it would look like this stacked up. It looks like it's going through the 2 points right there and right there. But this one it go through, it looks like
Two.
two boxes stacking like that. But the
Yep.
only thing that you have to account for
So.
is that it's decreasing instead of increasing. That means it's negative. So it's
Oh.
negative 2. Done. And you can prove this by graphing it. Yeah,
Okay.
if you graph it, you will know that it will look just like this. You punch in the graphing calculator, it will look just like this. Done.
Okay.
Yeah, I think this is the best way.
That
And
makes
I'm pretty sure
sense.
this is the graph. I'm pretty sure this is exactly what it is. Yeah. How do I know? Because they gave you the 2 extra point for you to use. And it's so great to use the box for them instead of actually trying to use them in any other way. But yeah. Okay. Hope you're okay with that. So this is what I was telling you about the rational function. You see how I overlap the box? If it were
Mm-hmm.
this one, I don't know where I got the example from. This one, it'll be 3
Mm.
over x something something, but it's 3 over x here. If we say, let's say it's at the origin, and it's positive, by the way, y equals, I'm talking about this one here. This one would be y equals 2 over x for this one here.
Okay.
Yeah. So I remember I was trying to show you the number in front, I'm sorry, on the top of the x for the rational function.
So on the test, on one of the graphing problems, I forgot to include like that first box for some reason. So I went like an extra, it was like go up 2 boxes, except I went up like a third because I was like, oh, you don't include that first box, obviously.
Mm.
I don't know what I was thinking.
Oh, okay. I
No,
hope you,
it was just a stupid move. I do a lot of things like that, like I drop a negative.
oh man. Yeah, don't forget,
Yeah,
yeah, the negative. The parent function of this one will always face this way. Oops. So be careful with this one. This one is a
that's a
negative.
move I would do too.
Yeah, so
Like
this is a negative.
that's the parent function is flipped, and I was like, oh wait,
Yep,
never mind, it's not.
yep, yep. Yeah, I think many of you guys need more time to recognize, the transformation. But you need to know your parent function. But I think for even that, many of you guys still don't have them
I've been
down. Yeah, you don't have it down yet.
I've
Hey,
been
what up?
flashcarding the parent functions.
Okay, I'm glad. Okay, now what do you think about number 80 then? The absolute value, right? It's the absolute value.
Uh, for number 80, I got y equals the absolute value of x minus 3 plus 1.
Yeah, that looks right.
I don't know
Yes,
if that's
just
right.
that's right. It is right, just like that. Yep. Good job.
Okay.
All
I
right.
don't remember how I got it, but I got it somehow.
Now I'll make a variation of this. What if you have what if you need to get a two or something out of that? Let me show it to you right now. Just quickly, just in case. Let me do a grid. Let me bring in the grid. Sorry, we're running out of time here, but just quickly, okay?
Hmm.
So I'm making this up. If you if your V shape if your V shape somehow looks like this instead, like a little wider, you count the box. It's still the box method. See right here? That's two. See? Immediately,
Okay.
oh, careful on this one. It'll be one half. This will be one half if it's actually
Oh.
flattened down. But if it's stacked up
Oh, so then if it's like
like
smushed
like
closer
this,
together, that's
yes,
okay.
that it will be your two. Is that
Okay,
okay?
okay,
Yeah,
okay.
that'll be your two.